A warm welcome to one and all who gathered here to watch and hear hear our podcast. Um, we students of Barton, we are going to speak up about India's remote sensing. Before diving into the topic, I like to introduce our team. Myself, Vishnu, and our team consists of six members: Anandakrishnan, Adin, Narayan, Nandakrishnan, and Ananda Padmanabhan. Before starting, I like to give a short one line about remote sensing. It's a study about the topography and weather of a planet or an area. Further, our team will explain about remote sensing and other properties. I introduce Adin to speak up.
So, what exactly is remote sensing? Simply put, remote sensing is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation. This technology allows us to collect data about the Earth's surface without being physically present. It's like having a bird's eye view of our planet. Remote sensing encompasses both aerial and satellite imagery, making it an invaluable tool for a wide range of applications.
Thank you, Adin. Before we go into a topic, we always try to study about its history. So I invite Narayan to speak about the history and more details about remote sensing.
Everybody, good morning. And I am going to tell about the historical background of the remote sensing. The origin of remote sensing has been traced back to the earliest 20th century with an aerial photography, and this was the beginning of the remote sensing technology. And without a physical presence, they could image a background of any place, etc., with the help of remote sensing. And I am going to the historical background of remote sensing that was existed in our India. Our remote sensing was being started at 1917 by Aryabhatta, and some of them, it was one of the milestone of our Indian remote sensing history. And I am going more deep about that topic. About by saying the remote sensing in history, the Landsat 1 was one of the major one of the major satellite in which was being launched in 1972 by US satellite, and that was the first satellite which was initiating the model of the remote sensing. And the India observed the development and realizing the potential of satellite imagery for this is good. And this was one of its role model of Indian satellites for in the remote sensing. And when the ISRO, when the Indian Space Research Organization, established in 1969, began to exploring the satellite remote sensing technology under the vision of the leadership of Dr. Vikram Sarabhai, regarded as the father of the Indian space research program. And experimental stages, the India was being images from the Landsat and only the remote sensing application that makes mapping natural or resource vegetation. At that time, when the India was being starting for the and moving to the foot of independence, at that time they were want to cultivate according to the first action plan which was taken by the India. They want to know more and more about the agriculture facilities and the resources and some of the water bodies that was existed in our India at that time. For that, there was some of these type of satellites were very useful at that time. And some of the important satellites which has been mostly used for these purposes were Bhaskara 1, which was being launched in 1971 by the ISRO, and Bhaskara 2, which was being launched by in 1981. And it was the first India's Earth observation satellite. These satellites, other than remote sensing, they will also gives TV and microwave payload were fitted on this satellite, and they will collect data on the data on hydrology and forestry and land use, marked of Indian first step towards the realizing and remote sensing technology. The data utilization. The India used Bhaskara satellite for the application like drought assessment, flood, and mapping, agriculture monitoring. Forming of the IRS series, which is the Indian Remote Sensing Satellite Series. IR-1A was a major milestone. The India was first fully operational remote sensing satellite, and it was being launched in 1988. And the linear imaging self-scanning sensors. It carried the linear imaging sensor, which consists to capture high-resolution images for agriculture, forestry, water resources, and disaster management. And subsequent launches included in IRS-1B in 1991 and IRS-1C in 1995 and IRS-1D which was been launched in 1997 with increasing sensor capabilities and better spatial resolutions. And these satellites were widely used in the mapping, urban planning, disaster management, and environmental monitoring. And and the resource cast, which has been launched in 2030, which consists of multi-resolution, multi-spectra, and the Castrosat series. These were another satellite which was been built by India in 19. Sorry, it was being Castrosat was being launched in 2005, and which is also used for urban planning, defense, and infrastructure development. And these are some of the historical aspects that was been used in the ISRO, just begun by ISRO. Now also the researchers about the spectral sparse solutions and the remote sensing satellite has been still progressing. Now also we can see while watching the TV and every remote sensing which was been occurred due to the first movement and action plans of these type of remote sensing satellite. Thank you.
Thank you, Narayan. It's really a great knowledge to know about all of this. And before we go into next topic, I like to give a small science background about remote sensing. Really, remote sensing is the study of electromagnetic waves that are emitted and reflected in the surface of an area. We all know about the spectrums UV, IR, and absorption, etc. spectrums. We observe these spectrums from a distance from the area, and by observing this, we can understand the topography, composition in the atmosphere, and many more about the area. This is what every countries and institutions use to find the topography and weather of a planet. There are several techniques to determine remote sensing. The major two of them were aerial and satellite. It will be explained by Anandakrishnan.
Okay. Sun remote. Plants, offering a bird's eye view of its ever-changing landscape. That is what satellite remote sensing does. It uses satellites to capture detailed images of the Earth's surface, providing extensive coverage and the ability to monitor changes over time. This technology is invaluable for tracking environmental changes like deforestation, climate change, as well as urban growth. It helps scientists, city planners, and environmentalists make informed decisions to protect our planet and manage resources more effectively. Uh, Next is aerial remote sensing. Aerial remote sensing takes things to a closer level by using aircraft to gather data at lower altitude. This method is particularly advantageous for detailed mapping and the analysis of smaller areas, often providing higher resolution images than those captured by satellite. It is like having high-powered camera flying closer to the Earth, enabling precise observation and detailed study of specified regions. This makes it incredibly useful for tasks that require fine details such as urban planning, agriculture, and even disaster assessment.
Thank thank you, Anandakrishnan, for explaining about the methods of remote sensing. Before going to next topic, I'd like to give a thought about remote sensing. In India, remote sensing is done by two major institutions, Indian Institute of Remote Sensing and Indian Space Research Organization. Do anyone think this is important? That is remote sensing is important? We need to pay for remote sensing. We must think about that before. So as an answer, and the Padmanabhan will give the answer for that.
In India, remote sensing is mainly used in agriculture for crop monitoring, yield estimation, soil analysis, etc. It allows farmers to make informed decisions, optimize resource use, and it allows them to enhance productivity through precision farming. It also has applications in urban planning. It supports urban planning by providing data on land use, infrastructure development, and population growth. This information aids in sustainable city planning and management, addressing challenges like urban sprawl. It's also a crucial factor for in environmental monitoring. It allows us to monitor the environment for deforestation, land degradation. It allows us to assess the quality of water. It enables the timely intervention and the policy formulation to mitigate environmental issues. It's also used in disaster management. In remote areas, remote sensing provides critical data for assessing damage, planning evacuation routes, and coordinating relief efforts. It enhances the effectiveness of disaster management strategies in India.
Thank you, Padmanabhan. Now we have got a overview about why we are using remote sensing. We all know that youth's mind were creative and enthusiastic. Since we are students of GC Barton, we are proud to give an overview about one of our satellite program in our college, which is led by our seniors and faculties. It will be explained by Nandakrishnan.
Hi everyone. We have a student satellite program in our college. It's called Bartosat. It starts in January 2021. The inspiration for making an Bartosat satellite is the LPS Center Pujapura. They invented VSAT. It was successfully launched by ISRO. So it's a wonderful example for being successful. An engineering student can successful in space industry. So we have it's a nano satellite, and the project was initiated by Government Engineering College Barton Hill, and it's a rare opportunity to experience all the challenging aspects associated with the satellite design, manufacturing, launch and operation, Bartosat is an ambitious endeavor aimed at launching a 1-unit CubeSat into low Earth orbit. It means up to 400 kilometers from our Earth. We have a collaboration with X20. It is an Australian space company, and also with IST. We use a technology LoRa. It's called long range technology. The first time LoRa will use it to catch the images and video footages of Earth and the space. So this is the all basic idea about our Bartosat and student satellite program. Okay.
Thank you, Nandakrishnan. We are about to end our podcast. Before that, it's really crazy that humans started from a cave and developed to this much of technology. We started from cave and started agriculture by seeing weather and by only visual content of knowledge. Then we moved to satellites, and satellites give more data which leads to our development. The notable point is a small move from eye contact to satellite changed our view. Now we are using the same technology for the analysis of other exoplanets, which can be a greater improvement in our technology in future. I hope everyone enjoyed our podcast, and thank you for one and all who watched and heard, and thank you for my teammates who explained, and thank you.